This is part 4 of section 8.3. We're going to talk about some applications of radicals right now. We're going to talk about the Pythagorean theorem. I know you've dealt with this before, but we have not dealt with ones where we do not get exact answers, okay? As a reminder, the Pythagorean theorem only applies to a right triangle. I have this right here, a picture drawn, okay? It has a 90-degree angle. What we call the legs of a right triangle are the two sides that make up the right angle. So these two are your legs, and we always label the legs A and B. It does not matter which one you call which, okay? This side right here, that's called the hypotenuse, and that's what happens when you let ancient Greeks name things. You get hypotenuse. Anyway, it is the side directly opposite the right angle, and it is always the longest side of the triangle. This is something to keep in mind as you're working these problems. It will help you decide whether or not your answer is reasonable, okay? And we always label the hypotenuse C, okay? So if we have a right triangle and we have them labeled like this, we have the formula a squared plus b squared equals c squared. And this happens all the time, okay? We want to use the Pythagorean theorem to find the missing side. We want to give the exact answer, not the estimated answer. So that means we're not going to get a decimal approximation. We are going to simplify it and give our answers that may still have radicals in them, okay? So let's look at this one and figure out what we have missing, okay? I have one of the two legs missing, and so just because it matches this and for no other good reason, I'll call this one A, this one B, but this one is definitely C. I could have switched these two, okay? So I'm going to plug these into my formula. A squared plus B squared is equal to C squared, so 13 squared. Let's do these calculations. 5 squared is 25, plus b squared is equal to 13 squared, which is 169. Let's subtract 25 from both sides, and that is b squared is equal to 144. Okay, now what this is asking is saying what number times itself gives you 144? Well, this is asking you exactly the same thing. What number times itself gives you 144? So what we normally do here is that b is equal to the square root of 144 because it's asking the same thing. What number times itself gives you 144? Well, b is equal to whatever number times itself gives you 144. The square root of 144 is 12. Okay? So in this case, we got an exact, nice answer. Okay, let's try this here. I'm missing a side. Let's call this one A just because I did B on the other. These are my legs because they make up the right angle. This is 9. Just like up here, I said that the hypotenuse is always the largest number. We got 12 here, and that's true. There are a couple of other things you can do to kind of check your answer on these triangles, and I'll show you that at the end when we look at these, okay? So I have A missing here. And this will be B, and this is our hypotenuse in C. So I don't know what this number is, but it cannot be larger than 9. Okay? So I have A squared plus 6 squared is equal to 9 squared. I have A squared plus 36 is equal to 81. Now I subtract 36 from both sides, and I get A squared is equal to 45. So my A is equal to the square root of 45. Okay, we're supposed to give an exact answer, so I need to get a prime factorization of 45. And I glance through the ones I have here, and I do not seem to have a 45 anywhere. So let's take care of that. 45, well, it ends in a 5, so it's divisible by 5. And that gives me a 9. Which is 3 times 3. So this is going to be, the square root of 45 is going to be 3 times the square root of 5. And this is the answer they would want you to give. Okay, now I told you I want to check to make sure that this is smaller than 9. So even though this is my answer, I might want to plug it into my calculator and get an approximation just to see that it is definitely less than 9, and it is. It's about 6.7. And maybe I'll make a little note to myself, it's about 6.7 here, because there's some things I want to show you about triangles, okay? If you have a right triangle, your hypotenuse is always the longest side. That's always true. But what I'm about to show you here is true no matter what kind of triangle you have. If you add up any two sides, it needs to be larger than the other. So basically, A plus B has to be greater than C. A plus C has to be greater than B. And B plus C has to be greater than A. If you add up any two sides, it has to be larger than the other. And this is true for all triangles. So you have another way of kind of checking yourself. If I add up these two values, what did I get here at 12? 5 plus 12 is bigger than 13. 13 plus 5 is bigger than 12. Okay, and 12 plus 13 is bigger than 5. 9 plus 6 is bigger than, I'm using 6.7 to kind of check myself here. 6.7 plus 6 is bigger than 9, and so on. You can check yourself all the way around. Of course, it's not a complete check. It won't tell you that your answer is perfect or you have simplified it all the way, but it will give you an idea whether or not your answer is in the reasonable realm.